Hello profs, we are Team 1 from lab group FCE2. I'm Aryan and together with my group mates Manya and Akshay, we will be presenting to you our mini project for SC1015 in which we have created a fake news detector. Our project is based on the problem that in today's society it is increasingly difficult to discern fake news from real news, especially with the advent of generative AI and LLMs such as ChatGPT and more recently Google Gemini. Our data science problem is a classification problem, and we must classify particular news as fake or real. It is done by categorizing a particular piece of news's likelihood of being fake on a scale of 0 to 5. For this topic, we use 3 datasets, namely Liar, IFND, and Fake Edit. These are from Kaggle, Papers with Code, and Hugging Face, and we use 3 to get a larger amount and variety of data points for more accurate modeling. Our data cleaning and preparation was done by deleting duplicate and null values. We also dropped columns to maintain conformity and uniformity amongst all the dataset columns. As you can see here, we also replaced subject names by using misleading instead of by replacing misleading with misleading. This was done using a supervised machine learning model, cat bool classifier, to categorize the entries in our subject column in some of our datasets to follow one of 8 categories. These included topics such as COVID-19, violence, and politics. After this point, we concatenated the various datasets into one final clean data frame, upon which we carried out our exploratory data analysis, which will now be covered. We use a pie chart to see the percentage of various truth ratings in our dataset, and we see the training data majorly consists of fake news for a better learning rate. We also use a dual variable histogram for a number of articles by truth rating per country, and our insight was that American articles have a significantly higher proportion of articles. Next, we use a typical histogram of number of articles per country, and we see that American articles have a significantly higher proportion of articles with truth rating 0. Our heat map of country as a subject shows that the US governmental articles far outnumber the rest of the country and subject combinations. And by doing the typical histogram of average truth rating of subject, we see that the average truth rating of government articles is about 1.0, indicating that they are the majority of fake news. We then use a word cloud, which basically shows the most emphasized upon words in our dataset. And we limited this to truth ratings of 0, 1, and 2 to zero in on the fake news. And we see that fact check, new, say, look, and people are some of the most prominent words. We also apply ML principles. So we clean text, removing stop words like at, in a, etc. And we then use tokenization to turn words into tokens of fixed length. Vectorization then transformed the tokens into integer sequences or vectors for ML fitting. The model training was then done, training 2 models for comparison, and we did a metric evaluation of that. So, in our linear regression, it was a statistical technique used to model the relationship between a dependent variable and one or more independent variables by fitting a linear equation. In simple linear equation, you have one independent variable. For example, y equals mx plus b, yes. In multiple linear regression, you have multiple independent variables. Linear regression uses methods like ordinary least squares to minimize the sum of squared errors. Common evaluation metrics for linear regressions are R squared, mean squared error, and F1 score. An accuracy of 0.77 and an F1 score of 0.762 indicates a reasonable performance, where F1 score accounts for both precision and recall, balancing the trade-off between false positives and negatives. We also use neural networks. Neural networks are machine learning models inspired by the human brain, consisting of interconnected layers of nodes and neurons. The simplest type of neural network is a sequential model, where data flows from one layer to the next in a straight line. Our long short-term memory is a type of neural network designed to handle sequential data, and our F1 score is a measure of the model's accuracy in terms of both precision and recall. By comparing the linear regression and neural networks, we see that linear regression has an accuracy of 0.77 and F1 score of 0.762. The neural network, however, has an accuracy of 83.5. They are both useful, but they measure different aspects of performance. Accuracy is a straightforward measure of correct predictions, whereas F1 score accounts for the balance between precision and recall. Given the higher accuracy of neural network, it might be considered the better choice. Our data-driven insights are as follows, where we see that datasets skewed towards low truth ratings, suggesting prevalence of fake news, and also US articles show a high proportion of truth rating 0, indicating higher fake news prevalence. Secondly, we recommend to focus on monitoring and fact-checking American sources with high prevalence of low truth articles, and alongside all these others, to educate the public on spotting fake news and promote media literacy. Thank you.